Welcome to lesson 3.4, developing and applying the quadratic formula. So previously we have used a couple of methods to solve quadratic equations such as factoring or completing the square, but now we are going to develop a formula. So when a quadratic equation ax squared plus bx plus c equals 0 is solved by completing the square, a formula is generated that can be used to solve any quadratic equation. This equation is called the quadratic formula. We are going to do exactly as it says there and solve the equation by completing the square. So first we have to get rid of the a coefficient attached to the x squared, so we need to divide by a, and we get x squared plus b divided by a x plus c divided by a equals 0. Next step is to move our constant term to the right hand side of the equation as so. X squared plus b over ax equals minus c over a. Now we need to complete the square, and we take b divided by a and we're going to divide it by 2, and we're going to square that, which gives us b squared divided by 4a squared. Now we add that to both sides of the equation to complete the square, and we get x squared plus b divided by ax plus b squared divided by 4a squared equals b squared divided by 4a squared minus c divided by a. Now we need to factor our left-hand side of the equation, which has a perfect square factor of x plus b divided by 2a. That's all squared, and our right-hand side can become one fraction as b squared minus 4ac divided by 4a squared. Now we need to inverse our square by square rooting both sides of the equation, and we're left with x plus b divided by 2a equals plus or minus the square root of b squared minus 4ac divided by 4a squared. But we can simplify that square root, and we get x plus b over 2a equals the plus or minus square root of b squared minus 4ac divided by 2a. Solving for x, we find x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac all over 2a. And writing as one fraction, we find x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is our final answer and our solution to the quadratic equation. So the solution of the quadratic equation, ax squared plus bx plus c equals 0, where a, b, and c are constants and a cannot equal 0, is given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So now we're going to go ahead and use that formula to help us solve some quadratic equations. Example 1. Solve each equation. So here we have a quadratic equation, x squared plus 2x plus 7 equals 0. We cannot factor this equation because there are no two numbers that multiply to 7 and add to 2. So let's try and use our new quadratic formula. We have an equation of the form ax squared plus bx plus c equals 0, right? And here our a equals 1, our b equals 2, and our c equals 7. So now when we plug into our quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. We're going to use what we have for a, b, and c. Let's go ahead and plug in. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 7, all divided by 2 times 1. Simplifying, we get negative 2 plus or minus the square root of 4 minus 28, all divided by 2. Simplifying again, we get negative 2 plus or minus square root of negative 24 divided by 2. Here we're going to go ahead and stop because we have a square root of a negative here and we cannot have that. So this equation has no real roots. Let's take a look at a different one. B. X squared plus x minus 4 equals 0. So in this case, our a equals 1 again, b equals 1, and c equals negative 4. So our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in, we get negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4, all divided by 2 times 1. Simplifying, we hit negative 1 plus or minus the square root of 1 plus 16, all divided by 2. Then we get negative 1 plus or minus the square root of 17 divided by 2. From here, we cannot simplify anymore, so our roots of this equation are going to be x equals negative 1 plus root 17 divided by 2 and negative 1 minus root 17 divided by 2. Solutions to our quadratic equation. Perfect. We're going to go ahead and practice a little more, but if you would like, you can take the opportunity to pause and go ahead and do some questions on your own. Example 2. Solve each equation. 2x plus 1 multiplied by x minus 1 equals 5x. We need to write in the form ax squared plus bx plus c equals 0. So let's distribute this out and solve. We get 2x multiplied by x minus 1 plus 1 multiplied by x minus 1 equals 5x. 2x squared minus 2x plus x minus 1 equals 5x. 2x squared minus x minus 1 equals 5x. Set equation equal to 0, we get 2x squared minus 6x minus 1 equals 0. So here we have an a equaling 2, b equals negative 6, and c equals negative 1. Our formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Plugging in, we get negative times negative 6 plus or minus the square root of negative 6 all squared minus 4 times 2 times minus 1 all divided by 2 times 2. Fine, we get 6 plus or minus the square root of 36 plus 8 all divided by 4. Simplifying, we get 6 plus or minus the square root of 44 all divided by 4. Using our multiplication property of radicals, we can simplify this to 6 plus or minus 2 root 11 all divided by 4. And now we can factor out a 2 here, leaving us with 3 plus or minus square root 11 divided by 2 as our most simplest solution. Hence, the roots here are x equals 3 plus root 11 divided by 2 and x equals 3 minus root 11 divided by 2. Let's simplify this and have integers coefficients so we can multiply by 4 here. And we get 2x squared minus 5x equals 12. Setting equation equal to 0, we have 2x squared minus 5x minus 12 equals 0. So now we have a quadratic equation of the form ax squared plus bx plus c equals 0. with A equaling 2, B equals -5, and C equals -12. So let's go ahead and use our quadratic equation here of -b plus or minus square root of b squared minus 4ac all divided by 2a. Plugging in, we get negative times -5 plus or minus the square root of -5 squared minus 4 times 2 times -12 all divided by 2 times 2. Then we get 5 plus or minus the square root of 25 plus 96 all divided by 4. Simplifying, we get 5 plus or minus the square root of 121 all divided by 4. 121 is a perfect square, so this comes 5 plus or minus 11 divided by 4. But we cannot simplify any further from there, so our roots here are going to be x equals 5 plus 11 divided by 4, which simplifies to 16 divided by 4, which equals 4. And 5 minus 11 divided by 4, which becomes -6 over 4, and simplifies to -3/2. So x equals 4 and x equals -3/2 are our solutions here. Let's try out a word problem here. Example 3. The surface area A of a cone with radius r and slant height s is given by the formula. A equals pi rs plus pi r squared. A cone has surface area 300 centimeters squared and slant height 15 centimeters. What is the radius of the cone to the nearest hundredth of a centimeter? So we want to know what r equals. And we are given that our surface area, which is A, equals 300 centimeters squared, and our slant height, which is S, equals 15 centimeters. So let's plug those into the given formula that we have. We will get 300 equals pi r 15 plus pi r squared. Now we can rewrite this so that we have a quadratic equation. It'll look like 0 equals pi r squared plus 15 pi r minus 300. So here we'll need to use our quadratic formula to solve, and we have an a equaling pi, a b with 15 pi, and our c equals -300. Plugging into our formula, x equals -b plus or minus the square root, b squared minus 4ac, all over 2a. We get -15 pi plus or minus the square root of 15 pi squared minus 4 times pi times -300, all divided by 2 pi. That simplifies to -15 pi plus or minus the square root of 225 pi squared plus 1200 pi, all over 2 pi. From this moment on, we are going to ignore our negative root, because that will give us a negative solution, and our radius does not equal a negative. Now we have x equals -15 pi plus the square root of 225 pi squared plus 1200 pi, all over 2a. Plugging into a calculator, we find that our radius r equals 4.8183, etc., etc. So our radius is approximately 4.82 centimeters for this cone, is our final solution.